Hi everyone, let's solve the problem of longest palindrome substring. And basically here we're given a string S, and given a string S we need to return the longest palindrome substring inside of S. And basically substring means a sequence of consecutive letters. So within S the substrings would be B, BA, BAB, BABA, and BABAD. So it can have any number of consecutive letters, but they have to be consecutive. So we need to find the longest substring, which is also a palindrome. Now, obviously, we know palindromes have the same letters if we start from the front or the back. So, for example, in this substring BAB, when we check from the first alphabet and the last alphabet, they will be the same. And then if it is an odd sequence of palindrome, let's say this one, the length of this is 3, it's an odd number. So when we check from the front and back, this will be the same, and then the middle will be a single alphabet, which is always a palindrome. Any single character is a palindrome in itself. And so when we have odd number of characters in a substring, we just have to check the front and back, and then the middle will be a character in itself. But let's say if we have an even number of characters in a substring, let's say if this is the substring. Now we know this is a palindrome because if we reverse this, it will also be C, then B, then B, and then C. And that gives us the same string, which is a palindrome. And how we can check this is basically going from front and back again, and then checking the second and the second last characters. So first we check C and C, then we check B and B, and then we don't have a middle character because it's an even because it's an even length. And that's our two cases for palindromes. Now in this question we're given a string and we need to find the longest palindrome. So let's say our string is this, which is the first example. Now there are a couple ways to do this. If we were to check the palindrome starting with each character, what we can do is basically start from here and then check, if this matches. If not, we know we can't take the whole string as a substring. So one option is we can derive all substrings from this string. So the number of substrings would be B, BA, BAB, BABA, and BABAD. Sorry, this is a bit messy, but basically these are all the substrings starting from B, and then similarly we can do substrings starting from A, which is the second character, and B, and then so on. So to get all the substrings of a given string will take, I think, n square of time, because for each character we are going through all the characters in the string and then getting the substring. Yeah, and then basically we can check for each substring and then check if each substring is a palindrome, which of these substrings is a palindrome, and then choose the longest one. But instead there is a better and a smoother process if we just know one trick. So in the string, let's say we want to find the substring starting from a given character B. Now, instead of starting from front and back like we usually do, what if we start from this character and then go left, right, and left? Sorry. So we can go right and left and check if those characters match, and then expand the substring outwards instead of checking inwards, So for each character, we can check outwards and then see if that forms a substring. For example, B is a palindrome in itself, right? So for B, we will have this as a palindrome, and this will be a result for now. The length is 1, right? Now, after checking right and left, we see there are no characters on the left-hand side of B. So we stop the process for B. That's all we can get from the character B. I'm going to write the result is B as of now with length 1. Now we do the same thing for A. For A, we have another palindrome, which is itself, and the length is 1, but we don't need to update it because, well, the length is not greater than the current result that we have, which is 1, right? So for now, for A, what we'll do is go outwards. We'll check right and left character and see if we can expand the palindrome outwards. When we do that, we see there's a character B on the right hand side of A and another B on the left hand side of A, which matches, right? So character on left matches character on right. And this will give us a longer palindrome. And our new palindrome would be, a new palindrome would be BAB. And this is for length 3. Now again, we do the same thing and try to expand further. We've already checked B and B. From here, we expand further to see if we can form an even longer palindrome. Here, when we go left, we see we go out of bounds, so we need to stop the process for A and then move forward. So basically, you get the idea of checking the palindrome outwards, and we do that similarly for B, A, and D. And I'll go a little faster just to calculate the results. So for B, we go outwards, we check the left and the right characters for B. We see they're equal, so we get another substring ABA, which is a palindrome. Now the length is also 3, which is similar to our result. We don't increase the length with this one, so we don't update our result. And we go forward. We try to go ahead, and then we check. We come across the left and right as B and D, and we see they're not equal, which is where we stop our expansion. So basically, we get this as our result. Now, we check this process for odd number of characters, right? Because if you see, for each character, we're going outwards. And then we're forming palindromes, which will always be in odd numbers because we take the mid character, we start at the middle character, and then we expand outwards. So the resulting palindrome will always be odd. Now, what if our result is actually an even number of palindrome? So let's say we have the second example, which is C, B, B, D. Now for this string, if we keep checking for each character and then we go outwards, our result will initially be this character, which is C. The length will be 1. Then it will go to B. It will try to expand. And we see C at left is not equal to the B at right, which is where, which is where we stop the process. And we continue doing that for B and D. And we see that they're also only 1 character long. But clearly we see our result here. We can form a palindrome with these two characters, which is B and B. And so instead of just checking for odd number of characters, what if we also check for even numbers starting at each character? And how that looks is basically, let's say if our I pointer is here, which is at 0, these are the indexes 0, 1, 2, 3. If our I is currently at 0, we want to take both I and I plus 1 as our starting points. So we will start our palindrome formation at C, B, but we check that these are not equal in the first place, so we can't form a longer palindrome from C and B because the mid values will never be equal. So we check I plus 1. For the first one, they don't match, which is why we don't go forward with that. Now when our I is at 1, we check if I and I plus 1 are equal. Well, good for us, they are. So we start our result at B and B, and the length is 2. And the result string is B and B. Now, if we go outward, if we try to expand outward, we see the left character is C and the right character is D. Now, clearly, C is not equal to D, which is why we won't carry forward with this palindrome. As of now, our result is 2 and our string is B and B. And we saw that if we expand it outwards, this does not work for us. Now, same way, if we go to I equal to 2, and we see is I and I plus 1 equal, we see that B and D are not equal, so we can't go forward with this. And, well, for the last character, we actually don't come to the last character itself because we're checking for I and I plus 1. So there will be no character after this, which is why this cannot form a palindrome except the character itself. So this will be a final result, and this will be the result that we give out. So I hope you got the gist of the solution here. Basically, what we do is we check for odd and even palindromes for each string, because our string can basically have the result, which is an odd number of characters, as we see in this one, or an even number of characters, as we see in this one. So for each character at basically index I, we want to check if you're able to form a palindrome with either of these. And with that, let's get started with the code. Well, so here's a code, and all we need to do is what we discussed in the problem statement itself. Basically, we form a separate function to check that starting at characters L and R, if you're able to expand outwards. First of all, we check if character at L equal to character at R. If this condition is true, which means we have a base palindrome from which we can expand outwards, and we do that for each character at index I for odd number of palindromes, and then we need to check for character at index I plus character at index I plus 1, which is for even number of palindromes. And so that's what we'll do. First of all, we'll start with this function, which checks a palindrome given our L and R indices. So we start at L, and we see while L and R are in bounds and the characters at L and R are equal, if only this condition fulfills, it means that it is a palindrome. It is still a palindrome. And if it is a palindrome, only then we can basically expand outwards. So we want to expand outwards till we see either L and R go out of bounds or there's a difference in characters. And once we expand outwards, we obviously want to update our result because it means we have a longer palindrome. And since the problem requires us to return the longest palindrome substring, we need to store the palindrome in result, which should be a string. The string goes from our left pointer to r+1. Well, in Python, this is exclusive. So it just goes from it goes from L to R, and it excludes r+1. And that will be our result. And we are storing the result length because we're slicing the result. We can also just store the result itself, but basically we're comparing if our window length, which is r minus L plus 1, is greater than the result length. Only then we update the result. Now we get r minus L plus 1 as the window length because if you see our example, which is PABAT, right? Initially, let's say our L pointer is here and our R pointer is here. At this point, our window length, as we see, is 3, right? And we start from 0, 1, 2, 3, 4. Our L is at 0, R is at 2. So for us to get the number of characters from 0 to 2, we do R minus L plus 1, which will give us 3. And so that is a window length, and we keep updating the window length and our result each time we want to expand outwards for a character. And once we have this helper function, all we need to do is for each character inside S, we want to check if we have an odd palindrome or an even palindrome, because remember, we can have either one. And for each character at I, we want to check for both possibilities of odd and even palindromes. And that's basically it. That will give us the result in the self.result variable where we're storing the result. This gives us the string, the result string, which will be the palindrome itself. In our case, it was PAB. And the result length would give us the actual length of the palindrome, which is 3. But basically in the output, we just need to return the result. And that's basically it. For the time and space complexity, you see for each character when we go outwards. For example, let's say we are at A and then we are checking outwards. So it's the worst case scenario is when we are at a character and we have to iterate through the whole string to check for a palindrome, right? Let's say if we start at B and then we go outward by one character. So first we check B, then we check A. This is also a palindrome. So we go further out and say, so for one character, we're checking the whole string, which is S. And for each character, we would have to do the same. So that would give us basically big O of n squared, where n is the number of characters in the string s. And our space complexity is 1 because we're only storing a result in variables and basically returning the result variable. And that's it for today. I hope this was clear. If you have any feedback, please feel free to drop it in the comments. And hope you have a great one.